All right, in the second set of notes, we're still introducing electrons. We're going to be focusing on certain types of electrons called valence electrons, and also how to draw Lewis structures. So electrons and stability. The nucleus of the atom, remember, it has protons and neutrons inside of it, doesn't change much unless it's radioactive. So electrons, though, are constantly moving within the atom, and they can be transferred to form bonds to gain stability in compounds. There is a principle called Heisenberg uncertainty principle, and it basically says it's impossible to determine the position and velocity of an electron simultaneously. So we do need to have somewhat of an idea of where electrons are so we can predict how they will behave. So even if we don't know exactly, we have some probability that we can work with. Valence electrons are the most important electrons for bonding, at least. The electrons are in the outermost energy level of an atom, which is called the valence shell. All the other electrons are referred to as core electrons. For main group elements, that means if you skip that middle part, which is the transition metals, the group number corresponds to the number of valence electrons. So, for example, group 1A, which has lithium, potassium, sodium, etc., that has one valence electron. The halogens on the other side of the table, group 8A, have 8 valence electrons. But remember, you would skip that middle part. These determine the behavior of atoms because having the same number of valence electrons gives elements similar properties. So all elements in group 2A, for example, that have 2 valence electrons, they are all behaving similarly. Stability. As far as stability, atoms are most stable when they have full outer energy levels of electrons. So there is something called the octet rule, and this is tendency of atoms to prefer to have 8 valence electrons. That is the overall rule, but there are always some exceptions. Noble gases are actually already have an octet, so that's why they're stable, and they don't need a bond. Other atoms, though, they need to do this. They need to either share if they're covalent, or they're going to gain or lose electrons and become ions, and then transfer electrons to make a bond. So stability is the key. So how they become stable, whether they share or they transfer, depends on what type of atom they are. So for example, sodium will give an electron to chlorine so they could become stable, because sodium has 1 valence electron and chlorine has 7. So if sodium gives away its 1 electron, chlorine that has 8, and sodium has this, basically the configuration of whatever element is before sodium. So this is where it would go, and this would form a bond. And that's table salt. If an atom gains or loses an electron, it becomes stable. It becomes an ion. This is some old stuff, but just as a reminder, ions are atoms or molecules that have a charge due to having lost or gained electrons. Remember, nothing happens in the nucleus as far as losing or gaining. That stays the same. It's just all about the electron. Cations are positively charged ions that have lost electrons. These are usually metals. For example, magnesium has 2 valence electrons, so it will lose 2 electrons and it becomes a 2+ charge, and it becomes magnesium cation. Anions are the opposite. They're negatively charged ions that have gained electrons. These are usually nonmetals. So for example, oxygen has 6 valence electrons, so it's going to gain 2 to become stable, creating a 2- charge, which then oxygen becomes oxide anion. And then we can also represent our number of electrons using what are called Lewis structures. So it's a convenient, simple way to represent an element and its valence electrons. Sometimes they call them Lewis dot diagrams or electron dot diagrams. What it shows us is what the element is and then how many electrons it has. So for example, lithium, if you look on the periodic table, it's in group 1A. It only has one valence electron. So we would just draw an electron on top. And depending on which resource you look at, there's different ways to do this. We will just start at the top, and then what you're going to do is go clockwise as you add electrons and double up once you have one on each side. So you'll see some practice in a second. When drawing, the nucleus is represented by the atomic symbol, so you'll draw that first and then draw the dots that represent electrons. You will look at the periodic table, determine the number of valence electrons from the group number, and then you'll draw dots around the chemical symbol. So fill one side at a time before you pair electrons up. Example, if we look at nitrogen, if you look at your periodic table, pause, get your periodic table if you haven't. All right, it's in group 5A. Group 5A has 5 valence electrons. So we would draw N because that is the chemical symbol for nitrogen. And then we would draw dots all the way around, and we double up on top. That's 5. So let's try these. See if you can practice these and pause this video, write in your notes what you think these are, and then unpause it when you're ready to check your work. All right, 711 is the practice. It is more Lewis structures. So you can try that out.